Okay, let's look at this maximum and minimum problem. This is a perfect example of it. We have a rectangular lot that one side of it is by ocean, and the other side of it is fenced by this 80 meters fencing. We want to know the largest possible area, or the largest possible dimension, or the dimension that gives you the largest possible lot. All right, so we have to go through this and make you a couple of equations. All right, let's do this systematically. Let's look at what 80 meters represent. Well, 80 meters from here, if the width, it doesn't matter, you can call it width, is that the x's, those are vertical, the y, the length, let's call it y. So we know that if we add them all up, 2x plus y, that would be equal to 80 meters. That's actually the perimeter of this rectangle, where one side is missing because one side of it is the ocean side, so there's no fencing there. All right, now how about the area? The area formula is, we know the area of a rectangle, and simply just x times y, the length times width. Okay, so these are the two equations that we have. All right, so let's manipulate the first equation, because we have xy for the area. We want to find what the area function is, right? So this is what we want to basically get to. To do that, let's rearrange the first equation. So 2x plus y equals 80. Let's solve that for y, and that will give us minus 2x plus 80. Great. So I just solved the first equation for y, and then I will go into the area function, and I'm going to substitute y value for what I just got. So this is the y right here, and this is the value of y. Okay, so I'm just going to substitute it right here for the area. So what do I have? X, all right, and the y is minus 2x plus 80, and that is the area function, okay, the expression that represents the area of this rectangle. Excellent. Let's do the math on that. So now we're going to expand that to x squared plus 80x. Great. I'm going to call this a for the area function. All right. Now that we get to this part, guess what you need to do? You need to go ahead and change this to the vertex form of a quadratic, and based on that we can look at it and see what would be the maximum value of the function. In this case, we want to find the maximum right here, the largest possible lot, the area we want. All right, so then we can go ahead and do that. So let's go ahead and do the completing the square method and then come back. Okay, so we're going to change that to the vertex form. First, we have to make sure that to do the completing the square method, the coefficient of the quadratic term has to be 1, so minus 2 has to come out. Factor that out, that's what we get. So what should we add now inside the bracket? So here we have minus 40, so minus 40 divided by 2, so that would be minus 20, and then square that. All right, and then you notice that we actually, what did we do? We did the 400 addition inside the bracket, but we actually did the minus 2 times 400. That means we have to add another 800 to the same side to balance that equation. All right, let's rewrite. Okay, when we change the perfect square trinomial inside, that becomes x minus 20 all squared. There's a minus 2 coefficient outside, and then plus 800 right there. All right, now we have the vertex form. What is the maximum and minimum value? First of all, remember, this graph is upside down. It opens down, so let's write it up. Opens down. That means it has a maximum. What is its maximum value? Maximum value is 800. That's 800 meters squared or whatever that is. Yeah, the unit is meters. So that would be the maximum value here. So would be 800 meters squared is the maximum value. Now, is the maximum area, right? But what is the dimension? What was the value of x? Remember, x was the width. This was the x. So we can actually know what x is because x is the vertex. So the vertex of this quadratic is 20, 800. 800 is the maximum value and 20 is the width measure. So 20 is the width measure. So let's write that up. So this is the x equals to 20, and if you want to find the width value, sorry, the length, which is the y, then we just use the first equation, 2x plus y equals to, 2x plus y, what was it equal to 80 meters? All right, so here we can say 40 because x is 20 plus y equals to 80. So sure enough, y will be equal to 40 meters. So here we go. We got this dimension. This is 40 meters, that's 20 meters, that's 20 meters, and it does make sense. When you multiply them, the area inside is 800 meters squared. These are all meters, by the way, all right? And the total will be 800. And this is the only dimension that gives you the maximum area, all right? That's how you will deal with the maximum minimum. Now, if I would have asked you to graph this, you should be able to graph this, and you can use the Desmos and go ahead and graph that. So when you have the answer y equal to 40, let's go ahead and use Desmos. So let's go to Desmos right now. So here is, I got the Desmos set up already, and in this case, what I want you to see is that you punch in the equation of the quadratic. Very good. I went in here, up here, and changed the graph settings, and I changed the x-axis from 0 to 100 because we cannot have a negative measurement when we are dealing with the real life situation, right? So the width has to be a positive value when we're doing the measurement of that rectangular fence. Also, the area has to be positive area, right? So here is the graph of this, but look, this is the maximum value. Happens at 800 meters squared when x is 20. Okay, now what I want you to see also is that the negative part of this graph, it's really irrelevant according to this, based on this specific problem. Okay, because we cannot have a negative measurement, we cannot have a negative area, so you can only use really the top piece, the first quadrant graph. All right, so here it is. The maximum value, which is the vertex value, that's 20, and 800. 800 is the maximum value, 20 is the x, and you can actually go ahead and come up with different values as well, but you notice that the only dimension that gives you the maximum value is 20 and 40. No other ones will give you that. All right,